So I'm going to use this presentation to really highlight how HRD has been working with both the Hurricane Center and the Environmental Modeling Center to exploit reconnaissance data for forecast improvement. But before I dig in, I really need to speak to the evolving use of reconnaissance data over the past 5 years or so. We've had a real paradigm shift that's been enabled by modeling and data assimilation improvements, and it's allowing for strategic sampling and smarter use of resources. This is really highlighted by these two figures here on the right. The top figure represents the old way of doing things. It's a typical C-130 alpha pattern that's been used for decades. This pattern was really geared towards observation of tropical cyclones, but not really towards forecast improvement. No thought was really put into forecast improvement when this pattern was designed. However, if you go to the bottom figure, Jason Dunyan spoke a bit about this. This is an ensemble sensitivity analysis. This shows us exactly where we need to be sampling the tropical cyclone to get the biggest bang for our buck out of individual observations. So this is experimental now. It's being used experimentally at the Hurricane Center, but it really represents the way of the future, the direction we want to be moving. Now, as I said, all of this is enabled by modeling and data assimilation improvements, and these two figures really show you how far we've come. On the left, we have a recon impact assessment for the 2013 HWRF. It shows us the impact of inter-core data assimilation of all that reconnaissance data. We had a big problem. You can see we have intensity error. Black is with the reconnaissance data, red is without it. And the first day, when we added the reconnaissance data in 2013 HWRF, we had much larger errors. This was associated with a vortex spin down. It was very undesirable, and it was a big problem. However, you fast forward to 2018, and it's a totally different story. You can see we have a recon impact assessment again, and you can see we improve the forecast almost systematically throughout the cycle. I also want to say that this 2018 sample was much more difficult. It was full of major hurricanes, category 3 through 5, which are much harder to get right with inter-core data assimilation than the 2013 sample. So it really shows you how far we've come in the past 5 years. One of those developments that made this possible was actually through an MCN HRD collaboration in 2018. The old way of doing things, the way EMC handled that vortex spin down, that degradation in the first day, was they actually removed the inter-core data impact. You can see on the left, high impact of the inter-core data would be from the red and the blue, the dark red and the dark blue. But in the middle, in the inner 150 kilometers, that 300-kilometer circle, we have no impact, the white. So they just got rid of the data impact. Now that did kind of solve the problem in the first day, but you want your reconnaissance data to be able to impact the forecast, of course. So we did some brainstorming between EMC and HRD and came up with a smarter way of applying the inter-core data impact in HWRF. On the right, you can see we have dark reds and dark blues, so we actually do have large impacts, but the way we came up with to get this data in did not cause the degradation in the first day. And you can see here the intensity errors from the old way of doing things in black, the new way of doing things in red. You can see they're systematically lower with the new way of doing things, and we don't have the degradation in the first day. That was a major milestone in HWRF in terms of getting this reconnaissance data in, and it's a big improvement going forward in the future. We've also worked closely with the Hurricane Center to improve the G4 usage, particular G4 dropsons. You can see we have 2 rings of dropsons around the G4. This is Hurricane Florence. You see 2 rings of dropsons. That's something new. In the past, we would only have 1 ring. But research here at HRD and elsewhere showed that when you drop more dropsons closer to the storm, it actually improves the track forecast. A fringe benefit of that is you get more tail Doppler radar data around the storm. In fact, HRD participated in an impact assessment of the tail Doppler radar, and you can see that here. This is for intensity bias in HWRF. Black is with the data, red is without. When you add this tail Doppler radar data, you see less adjustment in the first day, less negative bias. So we get 2 for 1. We have a track impact and an intensity impact. We've also worked closely with EMC to improve dropson usage. Historically, EMC has assimilated dropsons as a single column. Of course, dropsons move when you release them out of the plane. In this example, an inter-core dropson goes cyclonically around the center 15 kilometers. That's called dropson drift. When you account for this drift in HWRF, you improve the forecast. We have here intensity errors in HWRF without the drift in black, with the drift in red. You can see they're systematically lower when you account for this drift. This was a funded project through the JTTI program in NOAA. We had 2 transitions last year and this year. So it's at RL9. We're working to get this into GFS as well, so we can use all these inter-core dropsons in both HWRF and GFS. Finally, we've worked closely with the Hurricane Center to improve the C-130 dropson usage. In the past, there would be no dropsons at the turn point. So this is an typical alpha pattern from the C-130, and you can see the black dots represent dropsons. Back in 2017, I worked specifically with Mike Brennan to get these added, and we found that when you looked in HWRF, it improved the intensity forecast. So this is intensity forecast scale in HWRF. With the drops is better, without is worse. So this was an operational implementation. Now all these C-130 flights have dropsons. So in closing, we've really seen tremendous improvement in in recon usage over the past 5 years or so that's been enabled by multi-agency collaboration, and it's resulting in better forecasts and smarter use of resources. So next up, Gopal is going to speak about some of the modeling improvements we've seen to get where we are today.